Hello, this is Susan Poss. I'm working in Chapter 5, Section 1. We're beginning a new chapter dealing with all the exponent rules, and we'll be doing some multiplying and dividing with polynomials. So there's a lot coming up in this chapter. Here for Section 1, I've split it up into, I think, 4, maybe 5 videos. So this is my first one. So here's your definition of an exponential expression. An exponential expression is going to contain a base, which is the number that's written down on the line if you were writing on lined paper. And the exponent is a superscript, which is written up above, usually in a smaller font, and to the right of the base. And that exponent tells you how many times to use the base as a multiplier. So you can see here that first example that I have is a base 3 raised to the power 4. And you see I've expanded that out. I've written down the base 3 4 times. I'm using it as a multiplier 4 times. That gives me a result of 81. And if you wanted to type this in your calculator, most calculators have sort of an inverted V symbol on the keyboard, so you would type the base first, then that inverted V and the exponent next, and press execute or equals. Same thing, some other calculators have a little X raised to the Y power key. You type it in the same way, base, then access that function on the key, and then type the exponent 4. So you might want to practice to make sure you know how to type these. I did want to show you a couple of important examples here. The notation is important on these two. On the first one, the only thing that is considered the base is the 2 that's in parentheses. So you would write this 5 down only once, and the 2 is the part that would be written down 3 times as a multiplier, and that result would be 40. However, if the 5 is included inside the parentheses, as you see on this second example, you would need to take care of that multiplication inside the parentheses first, and then that base 10 would be used as your multiplier 3 times. So you want to be careful with the use of parentheses. All right, so we're going to start with our first rule here. It's called the product rule for exponents. And here's a simple example. We've got base 4 raised to the power 2 multiplied by base 4 raised to the power 5. And you can see off to the left how I've expanded these to show you 2 factors of 4 multiplied by 5 factors of 4. And of course, you can write that, writing down the base and then counting 1, 2, 3, 4, 5, 6, 7 factors of 4. And so what I want you to derive from that is that you don't have to go through all of that expansion. If you're multiplying 2 bases that are alike, and in this case they're both 4s, you can write down that common base and take these exponents and add them to get the result. So that's using a numeric base. The next example, I've got a variable base, x, and you can see I've expanded it again to reflect 3 factors of x times 2 factors of x times 6 factors of x. And of course, I'm just going to write that x down one time and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factors of x. And of course, we're deriving a rule here, so you could take this multiplication, and when you see that all the bases are the same, you can simply write down that base one time and then sum or add these exponents to come up with the base x raised to the power 11. And one other thing that I need to mention, I think you probably have already picked up on this in my previous work, but if you have a base and you don't see an exponent, it's understood to be 1. So in these examples here, this plain x is actually x to the first. this plain y is actually y to the first. So if I were multiplying over here to the right, I would want you to understand that that x contains an exponent of 1, and I would expect you to add 3 plus 2 plus 6, and don't forget to add that 1 in there for that additional factor of x. All right, so here's the rule. It says if you have a base x raised to a power m, multiply by a matching base x raised to a power n, the way you multiply those like bases together is you write down the base once and add up the exponents. And I'm suggesting out here that you would want to memorize this rule. There are going to be several of these, and if you can have them memorized, it will just make your work a lot easier. All right, so here are a couple of examples. So I'm multiplying. I see that the bases are in fact the same. They're both base z. So I'm going to write down the z. I'm going to add the 2 plus the 14, and the result is z to the 16th. Now I've given you one little thing out here to the left. If this is an addition operation, you cannot do anything with that, because those would be considered unlike terms. One has a power 2, the other has a power 14. So adding or subtracting, you couldn't do anything, but if you're multiplying like bases, that's when you add exponents. All right, so let me take this y, and I see a 7 plus a 5. And then there's a like base z, so you see how I'm keeping things matched up according to base. And so I'm going to end up with a y to the 12th and a z to the 4th. And again, just as a reminder, this z did not have a power on it, so we understand that power to be 1. All right, so those were just variables. Let's work a couple that actually have numbers in them. So here you're going to start by multiplying the numbers. 2 times 3, you're going to just get a 6 out of that. I don't mean equal, sorry. Times, and then I have a matching base y, one raised to a power 2 and the other raised to the power 9. So I'm going to add those up. All right, so the numbers 2 times 3, I multiply to get 6. The base y, I add the exponents to get 11. So you've got to be careful when you've got numbers involved. So here's a negative 3 multiplied by negative 7. I'll do that out in front. Here's a base m, and I'm going to add 4 plus 1. Here's a base n, and I'm going to add 4 plus 10. So here's a positive 21, multiplying those numbers together, adding the exponents, and adding the exponents. And last one, negative 5 times positive 3. Let me clean that up. I made a little bit of a mess. And then the base y, I'm going to take the 3 exponent and add it to the 4 exponent. So it looks like I'm going to end up out in front with a number negative 15, and then adding exponents here, 3 plus 4. All right, so I hope that's helpful in getting you started with your product rule. Let me work these quickly. And you can practice these along, making sure that you get the same answer that I'm getting. So it looks like negative 49, a to the 22nd, b to the 4th. So we'll stop there with our first rule.